In question 11a, you've been given a pentagon and we need to write down an expression for the perimeter of the pentagon, and we need to give our answer in its simplest form. So you can see that the pentagon has side lengths of x and 2x and 2x and x and 3x, right? Now it doesn't matter that we don't know what the x is, because all we'd have to do is collect these terms and make the expression. So write them down, and we've got 3x plus, or 1x, and the 1 isn't written in front of the x, so 3x, 1x, plus 2x, plus another 2x, plus another 1x. As long as you collect them all together, you're going to find out what the answer is. So 3, 4, 6, 8, 9. 9 x's. Nice and simple. In part B, we have to simplify fully this long expression. It's very similar to this one, but we've got some y terms as well as x terms and some number terms. So first of all, I'm going to collect the x terms together. So 4x, and that's a positive 4x, and 2x is going to give me 6x. I've got the y terms, which I'm going to put in a different shape. This is called collecting like terms. Careful with this one, because you've got 3y and you've got to take away 8y. So if you start with 3 and you take away 8, you get to minus 5. So minus 5y. And then you've got minus 2 and a minus 6. So if you start at minus 2 and you take away another 6, you get minus 8. Now that's fairly simple so far. In part C, we've got a shape A is a rectangle of length x centimeters and a width of 2 centimeters. And you can see that's not to scale. The shape below contains two rectangles that are identical to shape A. Work out an expression for the perimeter of this shape. So what we know is that this shape has exactly the same dimensions as this shape, or these two rectangles do, I should say. And again, it's just about collecting those like terms. So on the diagram, I'm going to draw what I know. So I'm going to put 2 centimeters as the measurement for this bit from here to here. We know that this bit is 2 centimeters. And we know that this bit here is x centimeters, according to the diagram at the top. And we go, again, we know this is 2 centimeters. And we know that this is x centimeters. Okay, but we don't know what this bit is yet. We can work it out, but we don't know what it is. We know this is 2 centimeters, and we know that this is x centimeters. So far, we've got pretty much all the way around. We're missing this bit. Now, the expression we could write for this bit, well, we know that this dotted line length here, this is 2 centimeters, because it's the same as this. So we know that that bit's 2 centimeters. And we know that all of this, the whole thing, is x centimeters. So we could write down this bit being x minus those 2 centimeters. So we'd write down x minus 2 centimeters. And that is the final part of the expression that we need to collect together, because all the side lengths are there, and we can now collect everything together. So that was the only bit that was missing. We've got 2 plus x plus 2 plus x. So I'm just going to count the x's. All right, we've got 1, 2, 3, that is a positive x, and 4. So we've got 4 x's, and then we've got plus 2, 4, 6, but then we've got to take away 2. So plus 4 would be our answer. So 4x plus 4, you could factorise that if you wanted to, and we'd be correct. But I think 4x plus 4 is a fine answer. If we were factorising it, we'd take out the factor of 4, and we'd put x plus 1 as our answer. I'm going to put that as our answer because it's just a little bit tidier. So 4 and then x plus 1. But you could write 4x plus 4 in this answer space and still get all 3 marks.